We're doing a project in biology where we're researching different diseases and we're figuring out like how they work out, like different like the cure, the life expectancy, the occurrence, what causes it, symptoms, and all that.
Okay.
And we were doing patient files and everything, but she asked me and a partner if we could do Hunter's disease.
Okay.
So we researched everything and we wanted to know we had some questions.
Okay.
So did you like keep up with the research? Do you still keep up with the research that's going on with it?
Some, not as much as I used to, but I have some friends who actually work for the National NPS Society. And so they've kind of kept me abreast of some of the research that's happening.
Mm-hmm.
So, I mean, I know that there are some trials that are happening right now for like intrathecal therapy, and they've done some trials where they're injecting enzyme directly into the brain to see, those are in the very early stages, so they don't have long-term results, but they do have some positive short-term results.
Okay. We were researching, and what treatments did you try? Because we kind of forgot.
So when my son was diagnosed, back in 2002, before he was even born, he had a diagnosis in utero, and there weren't really a whole lot of treatments. At UNC with Dr. Munzer, they were doing some enzyme replacement therapy, but they weren't having tremendous success with that. It was still in the very early stages. And you had to meet certain criteria in order to even get into the study. They were not taking infants at the time.
Okay.
So for us, the only option was to either treat symptoms and hope that a therapy would come about while he was alive, or they were doing some research at Duke University Medical Center in Durham, where they were working on unrelated umbilical cord blood transplants. So that's what we did with my son, was an unrelated umbilical cord blood transplant. So they take the stem cells out of the umbilical cord of a baby, which typically just gets thrown away. They don't use them. And those stem cells, they basically do a blood transfusion with them. And they go into the bone marrow and cause, in theory, cause the cells to produce that enzyme. For my son, the transplant only took about 50% instead of 100%. So he had severe graft versus host disease, which means like his the cells that were transplanted were battling his own cells, and it caused like all of this inflammation and caused a lot of problems within his cells. Like instead of rejecting the transplant was like attacking his body.
So it was making it worse?
Yeah.
Oh, okay. How did he inherit it again?
So it is X-linked recessive.
Mm-hmm.
I am a carrier for Hunter's. My husband is not, but since it's on that Y chromosome, then I passed on it's on the X chromosome. I passed on a mutated X. And so for like me, I have one mutated X and one non-mutated X, so I produce enough of the enzyme that I don't have any symptoms of the disease. I'm just a carrier because I have an X that produces the enzyme. But for my son, when I passed on that mutated X, he had an X and a Y, so he didn't have a non-mutated X to make that enzyme. And I know Miss Finley talked to you guys a little bit about like it can be like there can be a complete like different types of mutations. The type of mutation that I had, I didn't produce any enzyme. So he wasn't getting even just like a small amount, which sometimes that happens, like you just produce a smaller amount. He didn't produce any enzyme at all. So he had like the most severe form of Hunter's.
Oh, that's what I was gonna ask. Like, because we were researching, and for some reason, every page that we went to, it was like 10 to 20 years was our life expectancy.
Mm-hmm.
And then I wanted to know if his symptoms were worse, but based on what you have told me, like, I can tell that, like, certain things.
Yeah, so we knew, like, for him, because we had the genetic testing done before he was even born, we knew that his was going to be the most severe type of Hunter's, that he was going to produce no enzyme. So he probably would have been on that lower end of the range. for life expectancy. Like, he may have lived up to 10 years. Modern medicine, you can live longer. But we knew that would be a very painful, drawn out, slow deterioration. Like, it wouldn't be 10 years of quality. If we knew it was going to be 10 years of quality life, then we may have made a different decision. But it was not going to be. It was going to be 10 years of suffering before he finally succumbed to the disease, and we just didn't want that for him.
Is there anything like that that like we don't, because we know certain, like, the occurrence and like certain mode of inheritance, but were there any like symptoms or anything that he had that we don't know about? Or
so he didn't have any symptoms because he was transplanted as soon as he was born. Like, he had his transplant when he was only 6 weeks old, so he hadn't started developing any symptoms. But that's super rare, because most people who have a child with Hunter syndrome don't know that they're going to have a child with Hunter syndrome before the child is born. So, like, most kids don't get diagnosed with Hunter's until they're like 4 or 5 years old. That's when they start kind of getting symptoms. Like, for my uncle, who died even before I was born, so he died over 45 years ago. He had a lot of mucus and like had trouble with like breathing, and he had like some physical deformities. Like, they have thicker eyebrows and kind of coarse facial features. It's kind of hard to describe, but once you see a child with Hunter's, you're like, oh yeah, that's what that looks like. And so they thought that he had some type of breathing problems. He was actually diagnosed with cystic fibrosis when he was 3, but that was a misdiagnosis. And then they sent him to a geneticist because he wasn't getting better, but like the typical treatments for cystic fibrosis weren't really helping him either. Like, he wasn't getting any relief. So they sent him to a geneticist, and the geneticist took one look at him and said, this is MPS. Like, we need to have genetic testing for him. So, like, a doctor that's seen it can recognize it immediately, but a doctor who's never seen it, it's harder to diagnose. And since it's so rare, a lot of doctors have never seen it before. In this area, it's not as rare, but where I grew up in Illinois, there weren't as many cases. But because of Duke and UNC and like all of those big like the research hospitals being in this area, it's not like doctors are more aware of it around here, it seems like.
Well, those are all the questions I have.
All right.
So thank you. Our project is on Hunter's disease. Hunter's disease occurs in 1 in 100,000 people.
Hunter's disease official name is mucopolysaccharitis, which can also be shortened down into MPS2.
A child gets Hunter's disease, it affects their enzyme, and that affects their protein in the enzyme, and their proteins affect their DNA completely.
Some of the symptoms are enlarged head, thickening of the lips, and broad nose.
This chart shows you that the mode of inheritance is usually a mother carrier.
It is also a sex-linked recessive gene.
Sadly, there is no cure.
The average lifespan is only about 10 to 20 years.
Changes include problems with your lungs, your brain, your skeletal, your connective tissue, and your heart.